Hi everyone, my name is Anvita Bansal and we are back with another lecture from SDE Sheet, and today's problem is going to be anagrams. So let's have a quick look at the problem statement. Before that, let me check if you guys are able to see me. That's okay. Okay. So coming on to the problem, anagram, if you see in the sections string of your SDE sheet, let's see what the problem is. So let me just remove the solution. Okay, so you are given two strings A and B consisting of lowercase characters. Your task is to check whether two strings are anagrams of each other or not. If they are anagrams, you return true, otherwise you return false. The return type of this function is going to be of Boolean type. What are anagrams? Let's understand that. It's a very easy problem. Let's take a string. Let's say your string that I am giving you, A is listen. Let's assume A is one string and other string that you are comparing is silent. Okay. So are these strings anagrams of each other? So what is an anagram? Anagram is any string which contains exact number of characters as the other string, and those are same characters. The order can be different, but you need to have two strings such that they contain same characters no matter what the order is, and the length is also same. Okay, it cannot be a subsequence or a substring. They have to be the same length strings with the same characters present in each of them, but in the different order. Okay, so let's check. A contains L, B also contains L. They only have one L. L is present in both of them, that is coming out only once. Same goes for I. It is present only once and they both are present in A and B. The next character is S. S is present in both the strings only once. Okay, then you have T, and here I am writing the list of distinct characters found in both the strings and the count of it. So T is also coming once and it is present only once in both the strings. Other character is E, that is also coming once, and other is N, that is also coming once. So if you see, we have traversed over all the distinct characters. Is there any character I have missed? No. So I have covered the entire length of the strings, and each of them are coming out to be exact number of, the number of times they're occurring is also same. So yes, these two are anagrams. Let's check for EAT, TEA. So if you check what are the distinct characters A, E and T, and both of them are present on, each of them are present only once in both the strings, so this is also an anagram. Okay, then let's take one more example. Okay, let's say you have eat, another one is DEFEAT, defeat. Okay, so if you check, the distinct characters are in both the strings are different. Okay, the thing is, it also contains eat in it, and this entire word it's in itself is eat. But is it an anagram of, are they anagrams of each other? No, they are not anagrams. First reason, the length of strings are different. At this point only we can say that these are not anagrams. Two strings are anagrams only if they contain exact same characters in the same amount. Okay, so you don't have to find a subsequence here. That's why these are not anagrams. So first point of comparison itself fails. And even if, let's say, you are not comparing on the basis of length, you check that okay, it contains EAT. EAT is present here also, but E comes twice in the second string, and in first string you have E only once. So this itself tells you that these are not anagrams, because what I told, each character should be present in the same amount in the other string as well. Okay, so this is how you can identify anagrams. Now how can you solve this problem? How can you solve this? See, first thing that might come to your mind is that let's do one thing. Let's keep the one thing that you can, I don't know what comes to your mind first, but okay, let's discuss what can be done. First approach that I am telling you is going to be very simple, and I highly recommend not to solve the problem using this, because because this doesn't involve any critical thinking. What is it? Let's assume these are two character arrays, if I'm talking about Java, and you sort each of the strings. So when you sort each of the strings, your A becomes, what is the first character in the sorted order? You get E, okay, I, L, E, I, L, N, S and T, right? S and T. If I sort another character array, then the array becomes, you sort it, what is the character that should come first in the beginning in the sorted order? The one with the least priority, least ASCII value, so that will be E. Then the next one will be I. Basically you are simply using arrays.sort on your character array, right? Let it be capital A. So first thing that you need to do is, since in this problem you are given input in the type of string, so you convert the string to character array, right, using a.to char array. That thing you can use like this. Something like this. What do we use? A.char array. I'll show you what it is. So you can convert it to string using that method, okay, character array using that method. Okay, when I apply arrays.sort, why can I not apply arrays.sort directly on this string? You might be, if in case you might be wondering. So the reason is that arrays.sort is applicable only for arrays, and this is of type string. This is the reason I'm converting into character type array, okay. So on sorting it, it also comes to be EI followed by L, N, S, T. Now what you can do is, you can traverse on the string A and check if each character in the same order is equal to that indexed character in B, and you traverse over the entire length. If you find any mismatch, you return false. If you traverse the entire length and you do not find any mismatch, you return true. That means in the sorted order, if there is no mismatch in both the arrays, that means the strings are same, okay. So you return true in that case. I hope you have understood this approach. Fine. So now you just compare it from I equal to 0. Since they have to be of similar length, you can make a check in the beginning itself, or even if you don't, this will handle. Let's traverse over the length of A, I0, I is less than A dot length, and I plus plus, right? If A of, let's say this is capital A, this is capital A, this is capital B. If A of I is not equal to B of I at any index, okay, then you return false. And let's say you come out of this loop, you return true, okay. That's how you are handling it. You can also keep a check if the lengths are not same, length of A is not equal to length of B, you directly return false in that case. So that is about this approach, how much time it will take. So since you are sorting two arrays, so 2n log n of time complexity, right, and you are traversing over it once, so that is typically of big O of n. You're traversing once over this and then comparing if it's true. So predominantly it will become n log n of time complexity. Fine. Now I'll discuss another approach which is obviously taking less time than this, okay, but it is going to use some extra space, and it will involve a little critical thinking, a little bit of thinking, at least more than what we discussed here, although it's overall a very simple problem. So that is, let's take listen and silent as two examples we have taken here. This is A, this is B. What if I take a hash map? I take a hash map, and in my hash map I put up all the characters, distinct characters of A. This is basically a frequency map, okay, which is storing each character, distinct character, obviously that's the task of map, and its frequency, that is how many times that character is found in any of the strings. So I will use a hash map for A, and based on that I will compare the characters present in B. So when I create a hash map, I iterate over each character of array of this string A. I check if map does not contain that character, I add it to my hash map. So hash map will be of type character, right, and value will be of type integer. That's how your hash map will look like. Fine. So L is not present. What is the frequency? 1. The next character is I is not present, frequency 1. Same S, T, E, N, each of them will be of frequency 1 only. Fine. Okay, so let me take another example. Let's not better example. Let me take A is anything. Let me take it. B, D, B, C, D, and your B is S1. S1 is this, and your S2 is D, B, B, C, D. D, B, B, C, D. Okay, so I have chosen S1 and S2 to be anagrams. Accordingly, I have created this test case. So let's fill up the hash map. Hash map is going to look like what? I create a hash map using S1. So B is not found. I take B as key and add value 1. Then I find another D which is not already present in hash map. Count will be 1. Then I find B. I check B is already present and increment the value of B by 1. Then I see C is not present. I add it. D is present, so I make it 2. So your hash map will look like this. Now what? Now you iterate over S2, which is D, B, B, C, D. Okay. Now you ask your hash map. You iterate over each character and ask your hash map, are you present in my hash map which I found from S1, which I formed from S1? Hash map will say if map dot contains this character. Let's say my character char ch c is present at this, ch is present at this index. Okay, that is I equal to 0 as of now. I is equal to 0. I will ask my hash map, do you contain B? Map will say yes. So if you contain me, what is the count of it? Okay, whatever the count is, just reduce it by 1, which tells me that once I have already been consumed in S2, right? So I need to, for it to be an anagram, at least I want D to be present once more in S2 so that this count becomes 0 and I exhaust all the B of S1 in S2 as well, right? You need to have exact number of characters as it is in S1 for it to be an anagram. That is why I am reducing the count of B by 1, D by 1, because I have found it once. Sorry, ignore this. So it was 2 initially. Now it has reduced. I found D, so it will become 1 now. Okay, now you come at this position. I is equals to 1 now. So in that case, you ask your map, B is present, yes. So you reduce the count by 1 because you have found B once. Now you come at this position. Is B present? Yes, B is present. Reduce the count by 1, 0. Let's assume one more B was there. What you will do? You'll ask, see, map will say, when you ask if map dot contains this character, map will return you true for that. But see what is the count. That is not sufficient. You need to check what is the frequency, what is the value of that character. If the value is 0, that clearly means that you have found that character in S2, but in S1 there is no space for that character anymore. Means you have already found as many times it was present in S1. Now there is an extra character that you are finding in S2 which is not in S1. So clearly this indicates if map contains this character, if map contains it, map dot contains, but in that case if map dot get that particular character, whatever is, that is 0, that means you will simply return false, that you don't need to go further. You know that this is not going to be the case. So anyways, coming back to original problem that we were discussing, now B becomes 0. You move to another character, that is C. Ask your map, is C present? C says yes. Reduce the count to 0. Now you come to the last character, D. Is D present? Yes, and the count is also not 0 yet. You reduce it. Now what? There are no more characters to do, so you will return false. Okay, So this is typically what you are going to do. So hash map is going to take big O of n space complexity, right? That this is the space complexity. And what is the time complexity? Since you are iterating over one of the characters once to fill up the hash map, and on one string to fill up the hash map, but once you are iterating over the other string to compare the values present in hash map, both are the task taking place at different times. So that is typically big O of 2n of time complexity. So that will come out to be predominantly big O of n as a time complexity. So time complexity is also reduced as compared to the previous one, just that you are taking some extra space of on that is used for hash map here, right? So let me see if you have any doubts, else we can fine. Let's move to the problem and write the solution. Hash map. Let me bring it forward. Let me check if you guys are able to see me. Fine. Okay. Cool. So hash map is going to be of type character, then it is of type integer. Map is equals to new hash. I can also do one thing for char c belonging to int I equals 0, I is less than a dot length, right? I'm going to fill up the hash map I plus plus. Let's say char of c equals to a dot char at I. Let's do it. Then you are going to fill up your map. If map dot you can do one thing, use this map dot put what, this c, and map dot get or default against what. If it is already present, then not present, then this, and if not present, then 0. If it is already present, you are adding 1. I think I made some mistake. Against, this is the key. If this is the key is already present, then you add 1. Okay, so I have used a shorthand method. What it is doing, so this, in case you don't know, I am adding the character c. Map.get or default is it's a method or it's a function in hash map that does what? It checks, this is the key value, right? So key is c. Map.get or default will ask if c is present, right? If c is present, then it will return the value of c, right? And add 1 to it. If c is not present, then second value of this pair represents, if c is not present, add 0 as the value of this character c which you are putting, and add 1 to it. This is representing. So basically this is the default value that you should use if c is not already present, and then I am adding 1 to it, which tells that this map.get or default will tell you if c is present, it will give you the default value. Let's say this character c was a. G, it was already present, so what is its default value? Let's assume it is 1. So 1 plus 1, 2 will be added finally when you put it in your map. And let's say G was not present, so G will be added as a new character, and the default value they are asking, and the value that they are asking, you are giving as the default value. If it is not present, then you are adding 0, and then here plus 1, which is saying that G and its frequency will be 1. So this is what this get or default thing does. Okay, fine. So I have put this thing. Now what? Now you go and ask for int I equals 0. Same thing you are doing. Okay, come on, see. Fine. So this time character belongs to B. You are asking b dot length. Now what? So 1 second. extra. You have added to your map. Now you're iterating over B and asking if map dot contains key this character. If it contains key, then you should map dot put this particular character and map dot get C minus 1. This is what you should add, right? Also, if your map already contains it, in that case you have to check if map dot get C is greater than 0, that is it is 1, 2 and anything, then you are doing so. Else if map dot get is already 0, right? So these things you just need to understand the approach that I discussed, and these things you can handle on your own. This is how I am doing. You can do it any way you want. So else if map dot get 0, C is 0, you return false directly, which indicates, see, if map, you have found a character C, if map contains it, map will contain with the frequency 0 also. So you need to check if the frequency is greater than 0, good with us, just reduce the frequency and move ahead. Otherwise you check if it is present but frequency is 0, that means the case is that you are finding extra characters of that particular character in your string B, so you return false. So when you are not coming into this if case, that means you're finding a character which is present in B but not in A. So in that case also you return, if you do not hit the if case, you hit the else case. In that case also you return false, and if none of these cases hit your false case, then you finally come out of the loop and return true for the problem, right? So you come out of this for loop, if else for. Let's check our solution. Character integer. It should not take this much of time. That is done. Fine. So that was all about this problem. If you have any doubts, you can ask me, else we can wrap it up. So that is all about today, everyone. Let's wrap it up and see you on Monday. Thank you, everyone. Bye bye.